this video demonstration, we're going to show how you can extract data from Simulink to do manipulations and calculations in Matlab. So I've got a reactor system that I've used in a previous lecture. Don't need to be too concerned about the actual model that's going on here, but it's producing time series data, so I'm looking at reactor tank volume with respect to time. And what I want to do is I want to extract this data so that I can do more analysis in Matlab, which is such a powerful programming environment. So I go to my library browser and I go to Sinks. So instead of just sending my data to a scope, I can send that data to a number of different places, particularly directly to a file. So each time I run this Simulink model, it's going to update some file that's saved in a folder that you could access by Windows, or I can just send that data to the Matlab workspace. So I'll just send it to the Matlab workspace for now. So I drag and drop that workspace sync, and I connect that to whatever data stream I want. So it asks me about the type of format that I want to save it as. So I can save it as an array, or as a time series, or a structure with time. I'll save it as an array, and I'm going to call this variable v. And I can tell Simulink how frequently I want to sample this. So I'm running my simulation for 240 minutes, and let's say I want to get a sample every 1 minute. Otherwise, if I just leave a -1 in there, it says -1 for inherited. So Simulink may be taking hundreds or thousands of different of time steps to solve our system, and we may not want to deal with hundreds or thousands of data points. So I just want to deal with a sample every 1 minute. So I click OK. Remember, my variable is called v. So I run my system. So now, when I go back to my system, that v now shows up in my workspace. So I can come back here, I can hit v, and that gives me all the numerical values spaced at 1 minute intervals for that variable v. So in a real data collection system in a chemical plant or a refinery, your data should correspond to a timestamp. So you want to know at what time that point was collected. So if we want to collect our data in a different format, I'm going to go in here, and instead of just a plain array, let's say I want to collect the data as a time series. So the time series is going to be an object in Matlab that gives us a little bit more information about where that data came from. So I've just changed this from array to time series. I kept the sample time as 1 minute, and if I go back to Matlab, you can see now this is a 1x1 double time series. So when I go back and look at v, well, it looks a little funny. So now it gives me v, it gives me all of these different properties. So v is now an object or a structure in Matlab, and it contains the information about its time, and it also contains information about the actual measured data. So if I want to access that information, if I want to look at that same data, I can now access it by going v dot data will give me the data, and if I do v dot time, that gives me the range of time intervals that correspond to that data. So now basically this time series is a little bit more cumbersome to access our data, but it gives us this extra information. So now for any particular v, if I wanted to arrange these together, so now for any particular volume, I know what time that corresponds to. And it also makes it a little bit easier to plot. So now we can see I'm plotting the volume for each minute. So it's useful to extract all of your data from Simulink if you want to do other things like model fitting or analyze your data offline outside of the Simulink simulation. This can be a helpful tool.